So ever since I teased this chart, I've been thinking about how to explain it. And I've decided the answer is to not try too hard. Because I think it speaks for itself. I think the language it speaks in is a blood-curdling, eldritch language that will cause you to instantaneously lose organs if you were to use that language yourself, but I think it does speak. But it was really just me sort of charting out what my ideas were when I realized that I could use twisted pair to do wiring inside the broadcast desk, because I have definitely gone into that whole hog. You can kind of see I've got 3 twisted pairs going into a single cable and then breaking out into, or 3 links going into 1, then breaking back out into 3 again, just like that twisted pair snake I made in the last episode. Once I figured that out, I just spent some time and came up with this to give me an idea of what direction I was going to go in. First and foremost, I'm going to have to change something up that I talked about in the first episode, and that was a very sharp divide between analog and digital. And the part of the reason I have to do that is because I thought the R60s sent post-fader sends per channel. And they don't do that without some hacking. Hacking I'm not certain I want to do. So I'm just going to have to split off all of the signals and have one pair go into the R60 and the other pair go in the XR18, which is our digital interface, which is the thing that changes the wow-wows into the bleep-bloops. And this is not going to receive any fader information from the R60, so it's just going to record everything all out, except for the pair that specifically comes from the R60, from the R60 stereo output. So that's something that I'm going to have to change. I've already thought about, but I mean, the idea here is very basic. Here's the stuff that comes in, here's the wiring it goes into, and here's how it comes out. I've already decided I'm going to do 2 things a little bit differently. One, I'm not going to split CPU up between 2 different pieces of Cat5e. It's going to go into its own piece of Cat5e with 2 blank pairs for emergency expansion at some point in the future. And the strips on the R60s have AB selectors. So one strip can actually fade 2 different devices, just not at the same time. And the way we're using that here is basically you can either control a digital output device like a computer or an analog one like a CD player, which is technically in this case analog, or a vinyl player. So what we were going to have to do in the XR18 was collect them all regardless. Instead, I've ordered some signal relays. I'm going to make some logic-driven balanced audio switches. So I've really decided that I'm going to go with twisted pair wherever I can in this studio. Not only because it's cheap, but it also lets me use these nice little patch panels. And that way, we can have connections and disconnections between different parts of the broadcast desk. Because we lease this space and, you know, nonprofits being what they are, it's entirely probable that this studio will have to move. And if that's the case, and if I wire it up with one of these, moving all of these parts won't require the multi-month building process in the new studio that it did in this one. I also picked up one of these guys. I'm not talking about it. I just think they're really cute. We're going to be using these as generally available audio editing decks, basically just to run Audacity or VR. I'll let you know how it turns out. If you want me to do a video specifically on how that works out, I'm definitely into it. But otherwise, it's just more systems tomfoolery. Yeah. But for the rest of this episode, we're going to talk about these guys right here, the 528s. These are the voice processors, the mic processors, however you want to call them. I go through them. I look at them inside and out. we're going to look at the inside of a power supply, and we're going to talk about this whiteboard. So that's this episode. Okay. So this is kind of a complex test because I want to get a sense of how well the voice processors work here for the radio station. Now this is the things. These are the devices that take the raw input from the microphones and provide some modifications to them in order to make them sound nice and boomy and broadcasty, like you'll hear in my voiceover parts. So what we have in this particular test setup is we have my trusty RE320 microphone that I'll be using as a test microphone. And also to get a sense of what's going on, I also have my 150 ohm dummy load for testing things out on. Give me a sense of what it sounds like when there's nothing plugged into it, because if you just let it sit with nothing plugged into it, it's going to try and amplify itself, and that can create some problems. Before we talk about the device itself, also in the background in the computer here, I might do some insets from screenshots from this. I have Audacity, which is recording not only my lav mic here, but also the output of this so that I can listen to it later singly with my headphones, which I presently have on. I also have a scope up so that I can just look at the waveform, and I also have a spectrum analyzer here from CAF. And CAF is an interesting open source tool. It's actually what I use to replace this in my home studio, because in my home studio, the microphones go into a digital mixer, and then everything after that is entirely digital. It's a different setup than what we've got here. Because in that studio, I'm just saving space and power and all that. It would just made more sense to be digital, where here I have the benefit of being a little bit analog. So the voice processor here, the thing that's processing the microphone, is a Symetric 528, which is a device I have never worked with before, but have heard quite a bit about here and there from other broadcast guys who, have things like budgets. And what this does is a number of things that one would expect from a microphone processor. We have a de-esser, which is exactly what it sounds like. It's a thing that takes the sharpness off of your sibilant noises. It just sort of takes the punch out of them. I find it pretty important in broadcasting applications. It's a pretty common thing. The other thing, the next thing is a compressor. And what a compressor is, it's called a compressor. Its full name is a dynamic range compressor. I could go on about compressors for a long time. And in fact, in my when I teach production, I do spend a lot of time talking about compressors, when they're usable, when you probably shouldn't use them, where I like to use them, where I don't. But for the most part, when we're talking about talk radio, I compress things unto death. And what a compressor does at the end of the day is that it compresses the difference between quiet noises and loud noises. It makes the loud noises less loud, and it makes the quiet noises less quiet, so that everything kind of sits at the same volume level, and then you can adjust accordingly to fit your needed loudness requirements. And in talk radio, there's sort of a language of radio where if you're talking quietly and then you start screaming, you might spook your listeners, and they might, hit a fire hydrant or something like that. So compression is good. The next thing here is the EQ, which is just it's a standard 3-band EQ where you can set the bandwidth, the frequency, and it's just like any EQ you've used anywhere. If you've used an EQ, each section has a bypass, and right now they were all bypass, or the compressor was bypassed, but everything was fine. And then you finally have sort of an output gain knob where it just adds some amplification on the way out. And then you have this nice digital meter here, which you can switch between watching the compression, so where you could see the output level, and then you can see the gain reduction. Right now we're looking at the compressor gain reduction, and then you can press this button and you're looking at the amount of gain reduction when the de-esser is being used. And yeah, see? Sorry to make some horrible noise, but it gives you some ideas. Now, I'm I'm doing the time-honored thing where some engineer has helpfully created marks on the device where things should be, and I am taking that advice at least for this test. But I am going to twiddle all the knobs because I'm going to be listening for static, because I'm listening for bad potentiometers or bad pots. So nobody wants bad pot, so you need to make sure they're all clean. So I'm going to switch to the microphone I'm testing on now. Hello. Yeah, this sounds pretty good. It is picking up my breath noises pretty good, which is something I'm not a big fan of. I actually use something called a noise gate before the de-esser. In order to prevent that, this doesn't have a noise gate. But you don't necessarily need one. With the right compressor settings, you can usually get away without it. So, let's start twiddling some knobs. Yeah, that looks pretty good. Hello. All right, so here's the de-esser. Let's see. I'm going to turn the DS frequency down and the DS range way down. All right, so you can get a really clear idea of what it's doing. So, well, here, I'll turn that up. So if I go so that's your de-esser. That's what that does. And that's good. Okay, so the compressor, as I said before, we are clipping a little bit. That gives me a chance to check the preamp gain. I can turn that down a little bit. Oh, that sounds much nicer now, doesn't it? But then I'm going to want to cut up the output gain a little bit. Ooh, that sounds way better. All right, so here's the thing: is I'm talking quietly. Hello, how are you? How are things? But suddenly I get excited and I'm talking louder. Oh my God, so much more frequencies. Oh, so much amplitude. But you really can't tell now that I'm talking quietly because that's what a compressor does. So if I turn the compressor off, if I bypass the compressor, I can talk quietly. Hey, how's it going? How are you? And then I start screaming and yeah, it's no good. You'll notice you may have jumped a little bit. That's no good. If I turn the compressor back on, I can talk quietly and, that's all nice. But then I get angry. But it's not this huge change in loudness. It's just a change in tone. So the emotionality of what I'm doing is still Rush Limbaugh at you, but not any of the ear splitting loudness that generally comes from your standard Thanksgiving gathering. And then, like I said, the EQ here. I'm not big on EQing people too much, only to sort of counteract some things. Okay, that switch needs some work. Yeah. That just needs to be worked. All right, I think that one's getting the can of air treatment. Ooh. All right. This is in pretty good shape, actually. Yeah. I'm liking this. This is in good shape. Yeah. All right. Well, that's what we're looking at. This microphone processor is working pretty good. Sounds pretty good. I can get the sense of why people like them. So I'm going to test the other ones. I'm going to test the other ones, and I'll be recording as I'm doing it. But I'm not going to show you unless something interesting happens, because it's literally just going to be taking this one off, putting another one on, and plugging it in and seeing what it sounds like. So yeah, this one passes. I don't like the crackliness, but it's not much. And chances are I don't think I'm gonna worry about this, because this is gonna be a set it and forget it kind of thing. All right, next one. Okay, so here we have the only one I've discovered with a problem, and it's just a bad potentiometer on the output gain. So here, to give you an example, if I turn it down all the way, I am not getting any particular loss in gain until I get to the very end, and then it just cuts out. But if I go, and then going the other way, you see there's occasional spikes like this, and then now I'm at 0. And then I go up, and then I get close to the top, and then it just, whoa, suddenly it's super loud. So that's what, this is the kind of problem. This is a potentiometer that was set to one setting and then just left forever. So I'm probably going to pull out, open this guy up, figure out what kind of potentiometer it is, and then order a replacement and drop that in there. And then that'll be good to go, and we won't have to worry about that. So this is the third one, though. So all three of these are working pretty good. I'm not seeing a problem here. These guys are good to go. There is one other. All right, so this guy is the only one of these that I've got. It's the Symetric's 528E. It's the upgraded version of the device. It separates out more of the preamp, adds a few more features. It has a downward expander and a compressor instead of just a compressor. It's a low EQ, you know, the EQ's all there. That's pretty much the same. It's just laid out a little bit differently. Kind of an updated version. About the only thing that I can say I've noticed so far, given that I haven't plugged it in yet, this one has takes a PC power cable, or whatever you want to call that standard. You know, your standard 3-prong component cable. However, this one, instead of using a TRS for a balanced output, uses a standard XLR. So I have to hop to a different cable. I can plug my input into the line input, or microphone input rather. Don't need phantom power. And once again, I'm going to use the marks handily left by a previous tech. And that looks pretty on to me. No, I said no phantom power. There we go. Hello? All right, let's see, are we hearing anything? Well, that's bad. All right. Okay, yeah, this guy has a bad pot here. All right. Otherwise, it seems to be working okay. Although I don't think the de-esser is working at all. Yeah. All right, that brought it back to life. Hello. Yeah, okay. That brought it back to life. Okay, so we're good there. This seems to be in good shape, except for the fact that it's got a bad potentiometer. Hello? All right, yeah, this seems to be pretty okay, except for the fact that we've got a bad pot here. So, although it's starting to clean up as I move it, it just might need canned air. I think we might only actually have a single bad pot in the whole thing. All right, great. Good to know. Okay, it is significantly later. Well, not significantly later, but it's a little bit later. I had to kind of stop and work on other things for a little while. Specifically, they had to listen to the daily briefing, which is a thing we do that I'll talk about in a bit. But I am here back at my desk. You'll notice that it has a different color, that it is a light blue versus the weird static kind of pattern that the thing that my desk normally has. This is just a sheet of poster board that I put down. That pattern of the desk, while it's really good for me seeing things that are sitting on it, it is seriously really hard for any video codec to deal with it, because it's basically white noise. So to simplify things and so that my video files can have a sane size, I decided to put this backing on and see if this helped at all. So that's what this is about. Anyway, I want to look on the inside of the Symetric's 528. Now, these were pulled from a working environment where they were regularly repaired, and in fact, many of them have repair labels on them, and this one was one that did. I think this was the one that was repaired in 2003, and has and is the oldest labeled device that I've got. The most recent one was labeled in 2009, and that's a good thing because these guys. Because these devices, they have electrolytic capacitors in them, and over time, over decades, electrolytic capacitors will fail. If you want to know how that works or why that's important, I would look elsewhere. It's something a lot of people talk about online, on your EE blogs and on various YouTube videos, so no reason for me to get into the details of that, but a electrolytic capacitor over time becomes a resistor, and that's a bad thing. So I wanted to get inside this guy, take a look, and see what I'm looking at, see what I might have to replace. Unlike a lot of gear, this one's definitely designed to be opened, which makes it nice. Almost done. But I want to get a sense of what's in here. I'm expecting to see a handful of op amps, a lot of capacitors of various types, and things like that. Okay. And I'm not disappointed. This is an SSM 2015 CA3046s 78M 15 CTs. Hot snot. Capacitors of many sizes, many shapes, and many makes. Some of them I recognize, most of them I don't. So this thing has the look, especially with the hot glue here, and these ceramics that have been obviously added after the fact here. Here, let's bring in for a closer look here. Yeah, this has definitely been worked on. Has definitely been recapped and has definitely been modified. So I'm going to go over this thing now. No reason for you to watch it, but I'm gonna look at it and recap it. Or not recap it. I'm going to look at it and then get a markdown of what the capacitors are. I'm going to look in another one as well. And yeah. Okay, well, here's another example of the 328. I'm seeing a lot of the same types of capacitors, but not in the same places. Another one has a completely different capacitor on it. You can see that the capacitor mod has not been done on this one. And okay, you can see I've gone over each capacitor and I hit it with a dry erase marker, just so that I know that I've documented it. And so now I know what electrolytics are in here, and I can order new ones if I need them. But these have been recapped, and so I am not worried about recapping these immediately. I might revisit these. I might revisit this in 5 or 6 years. When that 2009 sticker starts, looking like a long time ago. But from the way these things are acting, and from the way, and from the looks of these capacitors and the modifications that have been made, I'm feeling pretty comfortable using these things as is. So I'm going to do that, I think, for now. But I've got the list if I need it, and I've been inside of them, and everything looks pretty okay over here. So that's that. So the daily briefing, I mentioned it before. I should probably actually tell you what it is. The daily briefing is a thing that started out every day at 3 p.m. on KTQA, and it was basically just Becky and myself doing updates about the stay-at-home orders in Washington and what we were hearing from the state and regionally and whatnot of just what was going on with the coronavirus lockdown and treatments and where you could get tested and just information that was just generally available but was widely spread out. So it was just a way to get information in one place where anybody could look at it. And so when we hit phase 2, and when, earlier in the year and when things were looking pretty good, we went from daily at 3 p.m. to 3 times a week at 6 p.m. And we came up with this sort of, how we would follow the phases sort of plan, figuring that the worst was behind us. Well, that unfortunately doesn't appear to be the case. And even though we're technically still on phase 2, or a modified phase 2, I suppose, it's become clear that, at least in Pierce County, it's as bad as it was back in the beginning of the year. So we've gone into back to daily episodes. And so I needed to stop what I was doing here and assist Becky, who's mainly been driving that while I've been working here on the studio, and I am very thankful for that. But if you want to see what that sounds like, you can find that at daily.ktqa.org. Although I've been kind of hesitant to promote it because it's just an informational service. It's not a particularly interesting show if you don't live in Tacoma. And I'm also kind of getting tired of the fact that it's Becky's voice or my voice, especially my voice. This screw is dead. This screw is done for, isn't it? It doesn't look that bad, but it's definitely been shaved down. No matter how good this thing might look electronically, it's pretty beat up. But so that's that's one of the things that we've done. But I'm just tired of it being the Sam and Becky show on KTQA. We're kind of stuck that way with the lockdown and the fact that we don't have a functional studio. So that's part of the reason why getting this studio running is important to me, because we could totally have good COVID, separation, good hygiene, and still have this particular studio available to other people. That's not something I can do. That was never the plan for my home studio. Now this here is the power supply for my R60. So it's an Audio Arts model PS6040. And unlike the power supplies unlike the microphone processors where they show that they've been worked on and that, the caps look different. I only have 2 of these because I have 2 boards. I have a spare parts board and I have this board. I don't know that these have ever been recapped. And this is a power supply, and this is a place where a failing capacitor can be pretty critical, because it could fail in a weird way and then suddenly you're passing mains straight into an audio circuit, and that's no good. Now, fortunately, I have documentation for this board, and so I know what capacitors I need to order to recap this, but it's still nice to get a look at it and get a spot check. And this is pretty much precisely how I thought it was going to look. There's not a whole lot to this. It's 4, 5. Let's see. So according to the parts list, we've got one 10,000 microfarad at C18. That's probably going to be... That's it. That's this big guy here. So two C19 and C16 are 35 volt, 47,000 microfarads. C1, so C1 and C3 and C2 are all the same. They're 22 microfarads. Don't need to worry about them because they're tantalums. And then this is a 470 microfarad, 100 volt. Yeah, okay. This looks pretty good. And these are all nice capacitors. They might be getting on in age. So this board is probably going to get recapped, I'm thinking. The transformer looks good. Everything looks good. But this is going to be pretty... Got an 8 volt test point, 18 volt test point. This thing is going to be real easy to maintain. That's nice. Hooray for linear power supplies. I mean, switching power supplies are great, but man. All right. Well, I think that's enough poking around on the inside of equipment today. So let's look at some other stuff. And here's where the whiteboards came from. This is me, Becky, and Paul. If the phrase going up the mountain means anything to you regarding to me, Paul is the person I stay with. He's a patron, a very good friend of mine, friend of the shows and whatnot, and he's helping us out here. That wall, if you've seen it before, is just painted OSB, painted particle board. The tenant on the other side of that wall needed a closet well before we got here, so they knocked a hole in the wall and then put that up. And so it's just a closet, then the particle board, and then they painted it. And the only thing separating the two units is that particle board. So we decided to hang some sheetrock. And here I am helping Becky with her first cut. And now we're fitting it in place. Becky's first cut went slowly, as your first cut always is. So nothing special here, not even needing to spackle. What the sheetrock is doing here is just creating some sound dampening, because the tenant on the other side of that wall is an Islamic cultural center, and we really don't want to bother them with our noise if we can avoid it. So any little thing we can do to help out the sound, any sound problems ahead of time would be good. There's Becky's second cut, which went way better. Becky learns quickly. And then we're putting up, there you go. That's basically all we did. Now, interestingly enough, there were studs on the edges of the closet and then 18 inches in, but nothing in between. So I could use regular drywall screws in the first two rows on each end, but then I had to use smaller screws that would only screw into the particle board in the middle, which made it kind of fiddly, which is why I was having problems there. Now I'm working with some hardware cloth. I think of it as chicken wire, but chicken wire is the fancy hexagonal stuff now, and this is just hardware cloth. But we thought we'd back the whiteboard with some of this stuff in order to make magnets stick to it. And at this point, Sharon shows up to help out and to say hi to Paul. And so here's the laborious process of me cutting it up into little pieces. So this, I'll just tell you right now, this didn't work. It was a pain to get into place. It was even more of a pain to get the whiteboard material to go flush against the wall with the hardware cloth. And we put our masks on. Paul shows up. Here's where we're testing it with a magnet. It doesn't work that well. So at that point, we just give up. And we cut out about an hour of us wrapping that hardware cloth back up. So here comes the first piece of whiteboard, which is just white hardboard you can buy at a big box store for $15 a square. Super cheap, works great as a whiteboard material. It's a trick I learned from Becky because apparently teachers use it a lot when they need whiteboards in their classrooms, and it works great. Erasing if it's been up for a while is a problem, but I always have a spray cleaner on to take care of that. Becky originally got the wrong one cut, so she had to come in with a replacement. And so here's the replacement. We're fitting it in. And I don't know, we're just screwing it in. But, you know, with the whiteboard, with the sheetrock, we're hoping we get a little bit more sound dampening. There's other stuff we can do if this ends up not being enough. But then I need a whiteboard to think. I can draw my plans out visually, kind of get a sense of what I'm doing, and so having, and then also for drawing up schedules for the radio station. We always knew we were going to need a whiteboard, so having a big one like this is a big help. And then Becky cleaning, one of those like really satisfying things to watch with the dust. And now I wanted a whiteboard for my office, so we're putting up one in here using my patented find a wire, find a magnet, make a stud finder thing. Usually it's a hard drive magnet, but I didn't have one handy here. Using my phone to level it out, screwing it into the... Really, we thought maybe we would have whiteboards on both sides because we had the material to do it, so we might as well give it a shot. Here's Becky cleaning up again. I turn the camera around, look for a stud, and then... This is brick.
Damn it. So we need cement screws.
Yeah. So I'd like to thank Paul for helping me put up the whiteboard, and honestly, the more nice things I can say about Paul, the better. There aren't enough nice things in the world, to be honest. Paul has been a huge help to me time and time again. I'd also like to thank my patrons, which are the people you see before you. They help make this go. You can join my Patreon by clicking on the link in the description of this video. Access to my Patreon gets you these videos a little bit early, and some other stuff, some podcast extras, things like that. See you next week.